Hi, welcome to Lesson 6C, Arithmetic Sequences. The goal of today's lesson is to learn about and become comfortable using arithmetic sequences. As defined in the textbook, an arithmetic sequence is a sequence in which each term differs from the previous one by the same fixed number. It can also be referred to as an arithmetic progression. So if we take a look at this sequence here, -7, -4, -1, 2, 5, and 8, etc., etc. If we're told that this is an arithmetic sequence, we would realize that if we notice that the difference between each one is the same. So just to verify that, if we take the second term, -4, and we subtract the term before it, -4 minus -7 gives us 3. Then we take a look at -1 and we subtract the term before that, so we get -1 minus -4 to get 3 also. Then we can continue. 2 minus -1 gives us 3. 5 minus 2 gives us 3. 8 minus 5 gives us 3, etc., etc., etc. Now, if you're told that a sequence is arithmetic, you basically only need to perform one subtraction in order to determine what that common difference is, because all arithmetic sequences have a common difference between terms. So you don't have to do multiple subtractions like we've done here. The common difference is the fixed number by which the sequence increases or decreases. In general terms, you could determine the common difference by calculating one term, subtract the term before it, which would get UD, just like we did over here in this previous example. U sub n is any term in the sequence, and d is the common difference itself. Now, in the textbook, they discuss 3 consecutive terms of an arithmetic sequence, and it is shown that the middle term is actually the average of the first and third terms of those 3 consecutive terms, which is called the arithmetic mean. Okay, so if you'd like to explore more, you can go and check that out in the textbook. The general term is always very important to determine when we're discussing arithmetic sequences. We see that the pattern will develop, which allows us to determine that general term. So if we know that we're looking at an arithmetic sequence, we know that there's going to be some common difference, d. The first term of the sequence we know is going to be u sub 1. The second term, u sub 2, is u sub 1 plus that common difference, d. So u sub 2 is u1 plus d. Then if we move on to the third term is the second term plus that common difference. And the second term, as we saw up here, is actually the first term plus the common difference. So then the third term ends up being the first term plus 2 common differences to give us to that third term. Therefore, the third term is the first term plus 2 times the common difference. Then if we move along to the fourth term, we see that the fourth term is actually the third term plus a common difference. And we've already established that that third term is the first term plus 2 common differences. Therefore, we can say that the fourth term is the first term plus 3 common differences. Therefore, u sub 4 is u1 plus 3 times the common difference. Notice that when we look at the term number, is more noted here, term number 3, the coefficient of the common difference is 2. The term number 4, the common difference is, the coefficient of the common difference is 3. So in general terms, the general term of an arithmetic sequence is some term equals the very first term plus 1 less than the term number multiplied by that common difference. So for any arithmetic sequence with the first term u sub 1 and common difference d, the general term, or the nth term, is un equals u1 plus n minus 1d. Okay, so let's take a look at how that will work in a couple examples. Okay, so take a look at this sequence: 87, 83, 79, 75, and 71. We want to show that the sequence is arithmetic. Now, I mentioned earlier that if we're told it's arithmetic, we only have to do one subtraction. Now, we're not really told it's arithmetic, but we have to show that it is. So in this case, we will actually have to do more than just one subtraction here. So for part A, we'll take the second term, 83, and we'll subtract 87, and we get negative 4. Then we'll take term 79, the third term, and we'll subtract the term in front of that, which is 83. When we subtract those, we get negative 4. We'll then take 75 and we subtract 79. Oops, 79. And we get negative 4. And we could continue along here if we really wanted to. I don't really want to go too much further, but as we can see, the common difference is negative 4 for each of those. So therefore, because we get that negative 4 repeated each time, we can say, therefore, the sequence is arithmetic with the first term equal to 87 and the common difference d equal to negative 4. Okay, so that shows that it is arithmetic indeed. Part B, we want to find the formula for its general term. So I'll just put B down here. So we know the formula for an arithmetic sequence is u sub n equals u sub 1, the first term, plus the term number minus 1 times d. And so we can substitute in some of the values that we know. So u sub n is u1, which is 87, plus we don't know that common term, or sorry, the coefficient. We don't know the term number that we're dealing with because it's just a general term, and the common difference is negative 4. So now to get the the general term, what I'm going to do then is I'm going to expand in the negative 4 into the bracket, and then I'm going to simplify, and then that will give us the general term. So u sub n is 87 minus 4n plus 4. Therefore, the general term u sub n is 91 minus 4n. Okay, so that's the general term. Now moving along to C, we're going to use that general term to find what the 40th term is. So u sub 40 is 91 minus 4 times 40. Now we don't have to use the term before it because now we've expanded that in and we've simplified. So now we can just substitute in the 40 directly, which makes the calculation of any term number that we're looking for a little bit more straightforward. So we got 91 minus 160. So the 40th term, u sub 40, is negative 69. And now for D, we want to determine which term in the sequence is negative 297. Well, un, we'll use that as our negative 297. And then we substitute in all the other values that we know, or we're going to put in into the general term, 91 minus 4n. We can just rearrange this formula and start solving for n. So we subtract 91 from both sides, so we get negative 388 equals negative 4n. Then we divide both sides by negative 4, therefore n equals 97. Therefore, u sub 97, or the 97th term, is negative 297. Alright, let's move along to the next example.